So hey everyone, my name is Jesus Jackson, and I'm here to do a talk called Developing Rails Apps in Technical Isolation. So let's go and get started because we're running a few minutes late. So a little bit of a background on me and my team. I currently live in Washington, D.C. I've been a software developer for a while, and I've been leading a Ruby on Rails team for about 2 years. I'm also a developer advocate in a Java-based world. So you might ask yourself, what does that mean? Well, primarily my clients are government, and we all work in government spaces. And as you can probably imagine, most government projects are in Java. On my contract right now of about 150 to 200 developers, we have about 30 plus projects. My project is the only one that's Ruby on Rails. Every single other project is Java. So it's been an uphill battle that me and my team have had to face to really get Ruby on Rails on the map and really educate our clients and understanding the benefits of using Rails. So a little bit of background on my team. 15 developers. You might say it's a really large team, but my project is an umbrella project that covers 4 different projects. All the projects work in unison to deliver awesome solutions to our clients. Again, we're dealing with DoD clients in secure spaces. Well, what is a secure space? Like, what does that actually mean? Secure spaces means you're not allowed to bring cell phones. So the cell phone actually has to stay in the car. You're not able to actually code on the internet. Everything is on an intranet. It's really secure in the way of software. If you found some really cool gem and you're like, ooh, I really want to use this in my project, hold up. You have to go through a security team and get that gem validated first. They have to virus scan it. They might ask you some questions. You might have to fill out a form on what that gem is, who it's from, is the gem written by a foreign national, all sorts of stuff. So very secure spaces. So technical isolation, what does it actually mean? So it doesn't mean developing on an island. And I put that on there because when I got accepted to speak at RailsConf, I was really excited. I posted on Facebook. I was like, hey guys, I'm speaking at RailsConf. I'm like super duper excited. And my talk is, blah, 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 technical isolation. One of my friends goes, what does that mean? Like you're coding on a remote island? No, it doesn't mean that. But what it does mean is developing apps on an intranet. So you're part of an organization that's not connected to the internet or makes you go through red tape to connect to the internet. And you're forced to do everything on a restricted environment. The second thing is you may not have sudo privileges on the servers. You can't just do sudo as root, or you may not even be able to create your own user to sudo into. So no sudo privileges at all, completely gone. And you don't have control over your firewall rules. So say on your contract you have a bunch of other projects and you want to connect to their API. And say one project's API uses Tomcat, which I find out that we connect to a lot of Tomcat applications on my contract. And say you have to connect to 8443. Well, that port's going to be blocked automatically. All ports are blocked except for 80 and 8080 automatically. Even things like 25 for SMTP, you may have to get approved by a security team to get that open so you can go ahead and send emails. So that's what I mean when I say technical isolation. Raise your hand if you feel like you're working in an environment that has some or all of these attributes. Wow, that's awesome. All right. It's awesome and not awesome. What's awesome is that I'm hoping you guys are actually going to, it's awesome because you guys are here, and I'm hoping you guys will learn something from my talk that you can use in your projects and in your code bases. So what do? We deal with it. So look at this picture. When I was writing my slides, I was like, all right, you can look at this picture 2 different ways. You can say, like the man is telling you, just deal with it. Or you could say, no, we're going to deal with it, and we're going to roll up our sleeves and figure out these problems. That's what I'm talking about here. We're going to figure this out. How do we do this? So problem 1, using RVM. Everyone in here should know what RVM is. It's a great tool. Raise your hand if you use it in your projects. Pretty much everybody. Great. So how do we actually manage our Rubies and our great gem sets behind these types of environments that I described? Solution. There was a developer on my team by the name of Stephen Haddix. He created a really cool gem called VM Firewall. And what this essentially allows you to do allows you to use RVM on an internet or in a very restricted and extreme environment. You can find RVM Firewall at that link right there. There's his GitHub page. And it's a really simple app. It runs on Sinatra, and it works on any Fusion-enabled web server. So it works on Passenger, which is what my team uses. And the magic behind it, the meat behind the RVM, is just modifying the .rvm/user/db file and just changing it so it points to your internal references to your Rubies. So setting up RVM Firewall, really simple. First, you want to run a rake task called Bootstrap to download all your Rubies and packages. You're going to be doing this, on the internet. You're going to get all your tools, Rails, etc. Then you're going to want to go ahead and copy and deploy those contents onto your organization's intranet, your servers. That's a big step, is getting them there. Once you have that, the next step is to actually install RVM. You can do that using a basic curl command. The fourth step is configuring RVM. This is the main point right here, and really taking the database file that RVM gives you by default and going ahead and overriding it with the one that's provided by RVM Firewall. The last thing is just to do RVM reload, and boom, there we go. We have RVM. Let's talk a little bit more about it. How do we, once we get it set up, how do we use it? So what's great is that other projects on your network can now use your server for maintaining RVM instances and your Rubies. And when they actually download and use RVM Firewall on the intranet, they can go ahead and they can see all the Rubies via two different ways. They can go ahead and they can type in your host and port /db, and they'll get a list of all the Rubies that you host. Then they can copy and paste those contents into their /db file and then have everything point internally back to your information in your server. The next thing is, you can do RVM list known in the command prompt, and then you can get a list of known Rubies. So depending on how you want to see which Rubies are available, you can do that in one or two separate ways. So I'm going kind of fast here, but that's RVM. And RVM Firewall, again, it's a great tool. But the big so what there is not just being able to use RVM Firewall, but being able to, or essentially enabling your organization to use RVM Firewall with you. What my project did is we actually set it up, we set up a Ruby server we called RubyFoo, and we put a lot of cool stuff in there like Jenkins, and we put RVM Firewall, and then we allow other projects to connect to that. So we broadcasted that. We said to the government agency and all the Ruby projects, hey guys, here's RVM Firewall on this server, this port, go ahead and download it, follow these instructions, and then you can get all our Rubies and everything. And then they were like, sweet, that's awesome. And now over about a dozen projects right now on the contract and off the contract are using RVM Firewall, thanks to Stephen. Problem two is CapStrona. Again, great tool, very simple to use. But there are some gotchas when you're in a restricted and unrestricted environment. So CapStrona wasn't very difficult for us to set up initially. The big hurdle that we had to go through was set up key-based authentication. We were trying to use Telnet or FTP, but a problem is CapStrona doesn't allow those by default. So we had an uphill battle. Again, I mentioned Steven. Thanks to him, he really went ahead and went full throttle in getting that set up. One thing that CapStrona does by default is it tries to use sudo. Well, if you're in a restricted environment and you don't have sudo privileges, you don't want CapStrona to try to sudo as specific users and try to do the deployments that way. So in your deploy.rb file, you can set user sudo to false. So now I'm going to go through some of the tasks we have in our deploy.rb file that have made our life easier. The first is our passenger, Apache and a passenger are going to need to be able to view and write to releases and releases/public. So I have a task here. It's really simple and self-explanatory. We create a namespace called permissions. We have a description, and our task is called make public. And then we just go to change modification 775 to the release path, and then we do the same recursively to the release path in the public folders. Rescue, that's something that we use in our project, and we love it. We have an awesome notification system, and we have that managed via rescue workers. It's really important to really start and stop your workers before deployment. And this is a simple task that we have in our deploy.rb file that will allow you to do that. Similarly as before, we create a namespace. This one's called rescue. Our description is to stop the workers. Our task is called stop. and then we just run 2 commands. We change directory into share path/path, and then we go ahead and run the actual rake task to stop rescue. And then we like to be a little careful. We put an exception in there, so if anything blows up, we'll actually see something in the logs. So that's it for CapStrona. The next problem is especially important, testing emails. So your SMTP server could be locked down. So what does it mean to be locked down? Well, in our case, it was ActionMailer is trying to send email. We know that works, but security team says, oh no, on your dev box, you're not able to actually connect to the SMTP server. Have a nice day. Well, how do we test emails then? I know ActionMailer works, but I want to make sure my users are actually getting those emails. I want to make sure that the content of the email makes sense, the format makes sense. I want to see those emails. So that's what I mean when I say blocked. So by default, ActionMailer is set to send to your SMTP server via localhost on port 25. Well, again, that's not an option for us. So our SMTP server won't receive emails, or we're not able to go to a security team or whatever team you need to go talk to and say, set up an SMTP server for me, set up another one, I need to test my emails. That's essentially the problem that we're dealing with. So what are the solutions? Well, we have Mailcatcher. Mailcatcher is one of my favorite gems, and it runs a very lightweight SMTP server on your local host. It catches any emails sent to it and displays an awesome user interface. The only thing you have to do is configure your app to send mail to port SMTP, localhost 1025, and then you view mails at your local host in 1080. Very, very simple. Well, what does it look like? So here's an example of the Mailcatcher UI. It's pretty awesome. You can see who you got the email from, the recipients, the subject, and a date and timestamp when the message was received. You have choices of looking at the email in HTML, plain text, or you can see the source of the email. In this example, you can see that you can embed links, and you can attach pictures and view the pictures. This is what my team had to do to be able to test emails, and it works like a charm. We love Mailcatcher. Let's see, how are we on time? 2:20, great. So I have 5 problems total. So problem 4 is using Git. This is my favorite problem to talk about because I love Git. It's a distributed versioning control system. I'm pretty sure everyone in here uses it. My contract, we're not able to use it, or we can use it in very minimal means. The only way we can use it right now in my contract is we have someone who can set up a Git repository for you, but only one developer can have read and write access to the repo. So if you have a team of more than one developer, they don't allow that. So we don't really have true Git repo hosting on my contract. So how do we use Git in SVN world? It's a little bit of a background. Every project used and still uses SVN naturally. There's been a lot of headaches with trying to educate other developers and educate our clients on wanting to use Git. Git was very misunderstood, and a lot of misinformation flew. Some of the information that flew by was Git is very hard to use. And if anyone here uses Git, it's really not that difficult to use. There's a learning curve, but with everything else of great value, it's going to be some cost. You're going to have to learn something new. You're going to have to change the way that you think about solving problems and doing things. SVN is not Git, and Git is not SVN. So that's really the main problem that we had, is that you'd be on the floor and you'd explain to other developers, hey, Git's really cool. Well, I've heard it's really difficult. Or they used it, but they used it improperly. An example of using it improperly is using Git like it is SVN. Just pushing a bunch of changes to the server, never rebasing, and just being like, oh, why am I getting all these error messages? I don't like this. I'm going back to SVN. That's what I saw from a lot of developers. And there's a way of kind of easing the pain in using Git. There's a little nice tool called Git SVN. So this tool is awesome because it allows you to use Git locally. Your code base becomes a local repository on your machine, and then you're able to push all your changes to the SVN repo. So unbeknownst to the rest of the team, you're using Git, but everyone else is using SVN. This is a really great way of allowing your team to kind of just dip their feet, dip their toes in the water, and not make a huge commitment on using Git. What's really cool is you can use all the nifty features of Git, branching, merging, rebasing, and you can do that all locally. And so your work and your changes aren't going to affect anyone else in a negative way. They'll just see your code changes just like if you were using SVN locally. So 4 simple commands for using Git SVN. The first is you need to actually pull down the repository and you need to clone it in your local repo. To do that, you're going to be doing Git SVN clone, the URL, and -s. -s pretty much says that the way I have my tags, my branches are pretty standard and I'm not doing anything crazy with that. And then it's going to pull down the repo and handle everything for you. If you're using some sort of strange heuristic in terms of branching and tagging, you may have to specify how that hierarchy is when you're actually doing a Git SVN clone. The most important thing you want to do is actually do commits. Git commit -am and then your commit message. This is an awful commit message, by the way. Don't ever just say my awesome commit message. That's not good. They should always be descriptive. So again, you're committing locally without pushing the SVN server. So that's like the big benefit of a distributed version control system, right? Is being able to keep making changes locally and then doing a big push to the actual server. Well, the commit command allows you to do that. Now, when you're ready to actually make the changes, you do a git SVN decommit. This will push all of your changes to the SVN repo. Underneath the hood, it actually just makes a commit to SVN per change that you did. So if you made 10 changes locally and then you did a big push via decommit, it's just going to make 10 commits. So when your team looks at the commit log, they're going to say, oh, okay, Hazy's did 10 commits. Awesome. And finally, if you want to pull all the changes from the SVN repo and update your local repo, you do that via git SVN rebase. So there's a caveat with this. It's a small one, but you just have to be careful. Remember that you're still using SVN underneath the hood. That's really important. SVN history is linear. So there's 2 things you don't want to do. The first is, well, you want to rebase your work as much as possible. You constantly want to be pulling down the changes from the repo. And the second is you don't want to simultaneously interact with the Git repo. So if you have 2 repos, you have your team's SVN repo, and somehow an angel came down from the sky and was like, hey, here's a Git repo that you can connect to and communicate with. You don't want to simultaneously be pushing and pulling from those 2 servers. And one of the main reasons is that the command git SVN decommit rewrites your local Git to include a unique ID. It also changes the SHA-1 hashes and does a bunch of other stuff. You can read more about it, but just for the sake of this talk, keep it simple. Just do it, just be safe, and you'll have no issues. Another cool tool is GitLab. We set this up on my project internally just to play around with it, and we're slowly trying to get other Ruby projects to use it. What GitLab is essentially your own GitHub. So GitHub's awesome. Everyone uses it for low-side commercial work. That's great. But GitLab allows you to have multiple repos, and you can handle issues, wikis, merge requests, code reviews, just like you can in GitHub. But you can have this on your intranet, on your organization. So this is key. I mean, government contracts are usually really big. There's usually many, many, many projects on a government contract using different languages. Well, if you're in a lucky state where you have more than one project that uses Ruby on Rails, you can really have your own setup here with Git and be able to use GitLab pretty nicely. The last problem is managing gems. So we're on this intranet. How do we pull gems? You know, we can't just do gem install rspec, right? That's the thing I put in my abstract. We can't just do that. Gem install rspec and voila, we have testing. We can't do that. So how do we do that? The easiest way is that RubyGem comes with a command called gem server. This is really awesome because it gives you exactly what you need, but it's easy to do. Typing gem server will serve all of the gems that are already installed in your system on your local host address 8808. So if you visit the address in your browser, it'll provide all the gem details. If someone else or another project puts this in their gem file, they're going to connect and pull all of your gems really easily. And the last is when you install new gems, they'll automatically be available through the gem server. So really, really simple. There's something called Gem in a Box, which is really neat. I don't think the major release is out yet. And I don't think the 1.0 is out yet. But essentially it gives you the same features, but allows other people to push to your server, or allows you to push to your server. Really easy to set up. create the directory for storing the gems, modify the config.ru file, and then run the server. If I want to go ahead and push a gem, I can just do gem in a box and then the location of my gem, and there you have it. So thankfully, there were some people on the contract who set up a local gem server, and they have like an upload interface and everything on their website, and that's awesome. A lot of different teams in and outside of the government organization have been able to use the gem server. I'm not sure if they're using gem in a box, but there's a lot of other different ways you can set up a gem server as well. I found these two ways to be the easiest. So, in conclusion, it's not just government agencies that are really dealing with these problems. We have the banking industry that's very restrictive as well. Sometimes you could have the pharmaceutical or the healthcare industry. They're going to have their own environments. The clients are going to demand sometimes how you deal with gems, how you code. They're going to have all sorts of standards that they're going to try to levy on you. And rightfully so. They're the client. They're the ones who sign your checks, right? And you can use these tools and you can use these ways and methodologies of doing development to really make your project successful. My project has been around for about 3 years. I was not on the inception. I wasn't there during the inception of the project. There's a really smart guy named Galen Palmer who went ahead and wrote a lot of the code initially. I came onto the team, and me and him, Stephen Haddix, and some of the other developers really pushed really hard to get other people to really adopt these best practices and really get other people, like government clients, to really start using Ruby on Rails. We're slowly getting there. We're slowly educating our clients and understanding that most of what the government does is web applications. Java is not good for web applications. It's not. JVM is a great tool, but when it comes to web applications, Ruby on Rails, or even Django, Python, there's other great tools out there that you can use. Cool. Well, thanks a lot. Again, my name is Jesus Jackson. Thanks.